Okay, so we pick up in this next part, and all we really want to do with this slide is to look at the relationship. So we talked about if we were on a unit circle with a radius 1, that this would be the point 1, 0, and that this arc length right here is t. And then we said theta is our angle theta is equal to angle t, and we talked about this previous in the last lesson. So basically we can just say theta is equal to t radians, which allows us to then make this table where I gave you all your definitions in sine of t. Now we can say, well, that's the same thing as saying sine of theta, because from this point on, most often we're going to say sine of theta is equal to what? Cosine of theta is equal to what? So this just lets us feel comfortable about why we have that switch there. And the next thing we're going to do is find the exact values of trig functions of our quadrantal angles. And so take a minute and think if you can remember what a quadrantal angle is. Right? A quadrantal angle is going to be an angle that has an initial side that terminates on an axis. All right, so first of all, I'm just going to walk you through these quadrantal angles. We're going to start with the first one, and it's going to be just the 0. So whenever I go over 1 unit on a unit circle, I would be at this point 1, 0. So all the questions I'm going to ask you are going to be based in reference to this particular point. I'm going to ask you to sine. The sine of theta is equal to your y value. So what's the y value of this pair? 0. So sine of 0 is 0. Good. Cosine, by definition, was your cosine of theta is equal to x. What's the x value? 1. So we can see that's where this comes from. Tangent of 0 is going to be your y over your x. So your y value over your x value, which is represented right here, y over x, is equal to 0. Secant, your secant is going to be 1 over the x value. So the x value is here. So that's 1 over 1 is equal to 1. Now we look down here and they have these two on the bottom. Cosecant is defined by 1 over y. But if I have 1 over 0, you know 1 over 0 is undefined. Let me see if this will write. So 1 over 0, but we know that you can never have 0 in the denominator, so this is undefined or not defined. When we look at cotangent, the definition of cotangent is your x value over your y value, and you're going to have the same situation. So we look at the first quadrantal angle, and we're going to look at the next one. So we move along the axis, and now we have our 90-degree angle, which is represented by the ordered pair 0, 1. Sine of 90 is just going to be the y value, which is 1. Cosine of 90 is the x value, which is 0. Cosecant of 90 is going to be your 1 over your y. So 1 over 1 is 1. Cotangent is going to be x over y. So it's the x value divided by the y value, which is represented right here, 0, 1, simplifies to 0. And then tangent and secant are undefined because they have division by 0. And we look at pi. So we move from here, our angle terminates at -1, 0. So we're now answering all of our same trig questions by using this point -1, 0. Sine of 180 is 0. It's the y value. Cosine of 180, it's the x value, -1. Tangent is going to be your y over your x. So you will have 0 over -1, just 0. Secant, we will get that to simplify to be -1. Cosecant pi and cotangent pi are not defined. And our last quadrantal angle. So we go all the way around the 270. We use the point 0, -1. And we say sine of 270 is going to be your y value. The y value is -1. Cosine of 270, 0, so on and so forth. You should have the procedure by now. So you get -1, Cotangent of 270 is 0. Tangent is undefined, and secant is undefined in that position. And so here is your the chart that lists all of the things we just calculated. Okay, it's in a nice pretty form. Okay, so one of our first examples is to find the exact value. Now, sine of 3 pi, we've talked about a circle, but we said all the way around the circle is how many units? 2 pi, right? So now I'm asking you something about 3 pi, which is actually just coterminal. So if I went around 2 pi right here and then went one more pi, that leaves me at this position right here, which is the point -1, 0. So all of my calculations will come from here. What is the sine of this point? 0, the y value. So it's just 0. Done. Okay? Now, what do we do when we have a negative angle? That changes the direction in which we go. So our initial start is here, and I go 90 in the negative clockwise direction, 180, 270. So I stop right here, I draw my angle. This point on a unit circle is the ordered pair 0, 1. So what is the cosine of that? Well, the cosine of theta is just x. The x value is 0, so cosine of -270 is 0. So let's see a few examples of these on our own now. Alright, so this first one that I give you is the sine of 11 pi over 2. And your first thought is probably that you don't know what 11 pi over 2 are. I haven't given you a whole lot of information about that. So if you're uncomfortable with the pi, what's something you can do? Convert it over to degrees. So we've done that before. So let's just take a moment and convert this over to see if you feel more comfortable. We can either convert it to degrees and try to get it to something we're familiar with, see if it becomes one of our quadrantal angles, or we could subtract out revolutions of 2 pi. So first, let's just take a moment and convert this to degrees. Alright, so when I got 990 degrees, and I think about everything we've talked about so far, we haven't talked about 990 degrees. We've talked about a circle that has how many degrees? 360. Good. So if I want to take one of those revolutions out, I'm going to say, let me take one of the laps around the circle, and that would put me at 630 degrees. Well, that's still bigger than the one circle we've talked about of 360, so what do we do again? Let's take another revolution out. So that would be 360 degrees. And that leaves me with 270. Now, is 270 something that's on the unit circle that we've talked about? Yes. So now we're okay, and I'm going to say, all right, I want to know the sine of 270. We haven't talked a whole lot about it before, but these two, sine of 270 and the sine of 990, are called coterminal. And on a side note, coterminal just means that sine of 270, first of all, 270 degrees, if I started at my initial, went all the way around, puts me here. Okay, puts me at this location. If I was to do 990, that would start around 360. I would go around 360 more. And then that would put me at 630, and then I would go around and it would put me here to where I was at 990, but you can see they start and terminate in the exact same location, so the value of that point is going to be the same. So this is the point, order pair what on a unit circle? 0, -1. So basically our calculation is going to be the same. What is the sine of our given point? -1. Good. So we come back up here and we say sine of 11 pi over 2 is -1. Okay, considering tangent of 6 pi, I could do the same thing I did in the previous one and convert it to degrees so I feel comfortable with it and take revolutions out. Or, because it's just an even pi, I can remember that all the way around the circle is how many pi? One time around is 2 pi, so then if I went again, that would be what, 4 pi, and if I went again, I went 6 pi. So it still puts me in the same location, which is going to be here. What is the ordered pair associated with this point? With this point. What's that ordered pair? 1, 0. Great. All right, and now use your definition of tangent that we previously used. Tangent is your y over your x. So what's the y value over the x value? 0 divided by 1 is 0. So we would say tangent of 6 pi is equal to 0.